Natural phenomena such as forest fires, volcanic eruptions and dust storms, as well as anthropogenic activities including mining, agriculture, vehicular emissions, and industrial processes are just some of the contributors to air pollution. Some of these pollutants are composed of carbon monoxide, volatile organic compounds, nitrogen oxides, sulfur dioxides, metals, and suspended. Their presence in the atmosphere causes detrimental effects in humans and other living organisms when inhaled. Some of the long-term effects of air pollution include respiratory and cardiovascular diseases that can also result in cancer and death. Moreover, the presence of these pollutants in the air can also damage our environment. Carbon dioxide and methane in the atmosphere continues to increase the planet's temperature, thus exacerbating climate change. With this, our group aims to present how analytical chemistry plays a major role in studying these air pollutants and how to combat such problems.
Great examples of these applications are the West-Geiger method, the Saltzman method, and the ion chromatography. The West-Geiger method is primarily utilized to measure sulfur dioxide content in the atmosphere. Sulfur dioxide is from power plants and smelting plants. The West-Geiger method is primarily the collected SO2 will be reacted with sodium tetachlorate. The product of the reaction will be dichlorosulfito-mercurate 2 complex. The product of the previous reaction will be reacted with parallosanilin hydrochloride and formaldehyde to form parallosanilin metanase sulfonic acid. The said acid will be extracted and its volume will be measured. The volume measured is equal to the amount of SO2 detected.
Nitrogen oxides in the air can react in different chemical processes. For instance, nitrogen dioxides are used in the formation of nitric acid, which forms aerosols that are detrimental to the human health. Moreover, nitrogen dioxides are often present in areas where combustion normally occurs, such as cigarette areas, candles, and stoves. For instance, for determining its presence in the air, the Saltzman method is one of the analytical chemistry techniques used. This method requires the grease Saltzman reagent, which reacts with the nitrogen dioxide. The intensity of this red-pink dye will correspond to the concentration of the nitrogen oxide. This reagent has been one of the successful methods used since the 1960s.
The last method to discuss is the ion chromatography technique, which isolates ions and polar compounds in the air to quantify and assess whether hazardous substances are within safe thresholds. One study published its application in assessing the air quality in workplaces by determining the concentration of volatile inorganic acids such as hydrochloric acid, hydrobromic acid, and nitric acid. Quoting from the methodology of the researchers, the collection of the acids were done on impregnated quartz fiber filter, the extraction of acids with deionized water, and the analysis by ion chromatography with conductivity suppression. In general, the ion chromatography technique is considered to be efficient, effective, and a great option for environmental analysis. Clean air, clear skies, carefree people. These are the ideals achievable through the application of analytical chemistry on the issue of air pollution. In the fight against climate change and respiratory and cardiovascular diseases, the applications of analytical chemistry such as the West-Geiger method, the Saltzman method, and ion chromatography are some of our most valuable weapons. Let us breathe in the techniques of analytical chemistry to breathe out a clean, breathtaking future.